Okay, so hopefully you remember a little bit from identities from before break. If you were asked to establish this identity and you did have some of these rules that we saw yesterday, then hopefully you can recognize the cosine of pi over 2 plus theta as an alpha plus beta kind of problem. So on the left side, that pattern should be the cosine of pi over 2 times the cosine of theta. And then with that being a plus, this should be a minus, and then it's the sine of pi over 2 times the sine of theta. And let's see what we get out of this. What is the cosine of pi over 2 worth? Keep in mind the cosine of pi over 2 would be over here, right? Pi over 2 would be here. The coordinates there would be 0, 1, so the cosine is worth 0. So you get 0 times the cosine of theta minus the sine of pi over 2 is that 1, right? 1 times the sine of theta, and 0 times anything is? So this ends up being 1 minus the sine of theta, which is a negative sine of theta. So that works. Are we okay with that? Alright. This is the one that Matthew asked about more or less, except we had an alpha minus beta, but it's basically the same principle. So, contrary to some of the other ones here, we're actually going to work on the easier side here first. The reason we're going to work on alpha plus beta here is we want to split this into just multiplications of one of them. So sine alpha, sine beta, cosine beta, that kind of idea. So working on the left side, the tangent is the same thing as the sine divided by the cosine, right? Yes? Okay. And we're adding. And the rule for sines would be that you have the sine of alpha times the cosine of beta plus the cosine of alpha, and then it's the sine of beta. So we're going to use the formulas that we looked at yesterday. And then here it would be cosine alpha, cosine beta, and the cosine things are a little backwards, so this should be a negative. And then that's sine alpha, and then the sine of beta. Alright, and now we have to do this little trick. So this is what I asked about earlier. What can I do now? Anybody have an idea? I'm going to divide by this thing. And before you ask me why, I'd then say, well, just wait a moment, because this is just one of these tricks that hopefully you learn along the way. What happens when I do this? Well, I'm going to get sine alpha cosine beta divided by cosine alpha cosine beta plus the cosine of alpha and then the sine of beta divided by cosine alpha cosine beta, and then you do all of this in the denominator as well. So it's the cosine alpha cosine beta divided by cosine alpha cosine beta minus sine alpha sine beta cosine alpha cosine beta. Now that's a huge mess, but a ton of this stuff is going to cancel out, isn't it? Like this cosine beta here cancels with that one. So sine alpha divided by cosine alpha is what? Sine divided by cosine is? That's the tangent of alpha. On this one, the alphas cancel, so now you leave sine beta over cosine beta, which would be the tangent of beta. Something divided by itself is always 1. So that's 1 minus, and what do you get here? Sine alpha cosine alpha is tangent of alpha, and then the sine beta divided by the cosine beta is the tangent of beta. Yes? So that one works that way. Now trying to go back to our cheat sheet. Is that on our cheat sheet? Can't remember what's on the cheat sheet anymore. Does anybody have it on them? Want to take a look? If it's not on there, the reason that it's not on there is because you can establish it through an identity. So I have a feeling that I didn't put it on there for you. Okay, but if it's on there, then great. If it's not, then this is one more that you'd have to. Then this is one that you have to find on your own, sort of. All right. Establish the identity that tangent 2 pi minus theta, so I'm over here, is a negative tangent of theta. So given this structure here, I'm just going to fill in what I have. So I'm going to work on this. I'm going to work on the tangent of 2 pi minus theta, and I'm going to fill that in with this one being alpha and this one being beta. So this is supposed to be the tangent of 2 pi minus the tangent of theta. Wow. Yes? Divided by 1 plus the tangent of 2 pi times the tangent of theta. And then how much is the tangent of 2 pi worth? So on the unit circle, 2 pi would be over here. It's a full rotation. The location then would be 1, 0. And the tangent is sine over cosine, right? So it'd be 0 over 1, which is 0. And then this one is 0. And so you end up with a negative tangent of theta divided by 1, which is a negative tangent of theta. Yes? Another one. So we have a rule for this, and we don't have one for this. So you can work this one from either direction. In my notes, I worked on the cotangent first because I do know a relationship between the tangent and the cotangent, which is what? Cotangent of pi over 4 minus theta could be written as 1 over the tangent of pi over 4 minus theta. Is that right? Well, then I'm going to use this rule here, but I'll flip it along the way because now it's here in the bottom, so I just need to flip that. So what I end up with in the top would be 1 plus the tangent of alpha, which is pi over 4, times the tangent of beta, and the tangent of beta is theta. So I'm flipping this thing because it's 1 over, so I just finished the bottom one here. Now I need to pick up that one, and that's going to be in the denominator. So it's tangent alpha, which is the tangent of pi over 4, and it says minus the tangent of beta. So that's what I have at this point. And how much is the tangent of pi over 4? It's 1, right? It's 45 degrees, so that's 1. So it's 1 plus the tangent of theta divided by 1 minus the tangent of theta. That's not quite what I have yet here, is it? Yes? No? So we're going to cheat, and this may sound weird. The reason I'm going to cheat is because I need it to look like this, don't I? I want it to end up looking like this. Does that make sense? Because the tangent of something plus something, so this is a plus, so I need it to look like tangent alpha plus tangent beta 1 minus. So let's see, which parts do I have? Well, I have the tangent of beta in the right spot. So I have this in the right spot. That's supposed to be the tangent of alpha. The 1's right, and then this says only the tangent of beta. So somehow I need to shove a tangent of alpha in there. keeping in mind that what? The tangent of alpha is the tangent of alpha is pi over 4. And how much is the tangent of pi over 4? It is 1. So this one can be replaced with the tangent of pi over 4 plus the tangent of theta. That one we're going to leave because it's in the right spot, but then we're just going to slide a tangent of pi over 4 in over here because it's worth 1 anyway, so that I can get exactly the structure that I'm supposed to get over here. Does that make sense? Because now I have the structure that the formula says I'm supposed to get. So that sort of looks like cheating, but I'm just rewriting it to match what I need so that I can finish by saying, well, that is the tangent of pi over 4 plus theta. So that one doesn't work for a lot of these because only at the pi over 4 is the tangent 1. Well, that's not completely true. It's also 1 at, what is it, 5 pi over 4? But it's very limited how you can get this kind of a problem. It has to do with pi over 4 somehow. Okay? Alright. And what in the world does this mean? How do you do this? Yeah, ultimately I am going to draw some triangles here. Keep in mind that when it says inverse sine here, that actually is going to return an angle, isn't it? So this just says the cosine of one angle plus another angle. So if you can recognize this as, well, that's supposed to return an angle and this one does as well, then you have a structure for this, because this is just supposed to be cosine alpha times cosine beta plus sine alpha sine beta. Now the sine of alpha I already have, don't I? If the inverse sine, if 2 over 3 is supposed to be alpha, then the sine of alpha is 2 over 3, isn't it? Yes? And if you know that the sine of alpha is 2 over 3, with that being a 2 and that being a 3, then can you find out what the cosine of alpha is? I think so. It's 9 minus 4. This one should be the square root of 5. So that one's going to be the square root of 5 over 3. So let's see, what do I have? I have sine alpha and cosine alpha. So I'm good here, and I'm good here. Now I need to work on beta. Well, beta is a tangent. It just means that I have to find both of them. But if this is true, and that's a negative 3 over 4, and if that's beta, then the tangent of beta is a negative 3 over 4. In what quadrant do you have to be there? You are in quadrant 4, because the tangent runs from a negative pi over 2 to pi over 2 if it's related to the inverse. With that being the opposite side, that being the the adjacent, so it's a triangle that we're familiar with. So that means that the sine of beta, because this is representing beta, is a negative 3 over 5, and the cosine of beta is 4 over 5. So this is a problem that's tied to what we did in the previous chapter, and then now you can fill in this mess into the equation you have over here. So now you go cosine alpha, cosine beta, so it's cosine alpha square root of 5 over 3, cosine beta is 4 over 5, plus sine alpha. Did I write down? That should be a minus, shouldn't it? Yeah, thank you. Because the cosine rules are sort of backwards. If it's a plus, it's supposed to be a minus in here. So that needs to be a minus. Sine alpha is 2 over 3, and then the sine of beta is a negative 3 over 5. So what do we get out of that? 4 square root of 5 out of the first. That negative is going to make this negative a positive, so that's plus 6 divided by 15, and then that would be your answer. Okay? Any other questions on that one? Same idea here, except this is with the re-expressing one. So if that's alpha, that's beta, or beta, then you can write that the inverse cosine. So that means that the cosine of alpha is u. That means that the sine of alpha is the square root of 1 minus the cosine squared, which would be the square root of 1 minus u squared. Need to do the same thing for the sine. So if the inverse sine of something is beta, then the sine of beta is v, and this one ends up with finding the cosine beta. Then that would be cosine is 1 minus sine squared, so that would be 1 minus v squared. That's a v. And then you can fill it in. So this one again, that's not again. So this is a cosine of alpha minus beta, so that would be cosine alpha, cosine beta, plus sine alpha, sine beta. Pick up the parts that you just found. So cosine of alpha was u, cosine of beta was 1 minus v squared, plus the sine of alpha, the square root of 1 minus u squared, and the sine of beta, put parentheses around that one, the sine of beta is a v. Are we okay with that one? And I think luckily for you it looks like the tangents are on your cheat sheet, because the next slide says that these are the formulas you have on a cheat sheet. So tangents appear to be on it, so you don't have to memorize them or know how to find them based on the ones that are above it.